Alright class, now in this session we are going to start chapter number 21, exercise 21.1, in which we are going to discuss about the applications of integration. Right. The specific application we are going to use is how to find the area under the curve. Alright, that is the main goal of your O-level maths, how to find the area by using integration. Right? So before starting the exercise, I have listed the example here. It says the diagram shows part of the curve y equals to 4 upon x square, and that is your diagram. We need to find the area of the region A. Alright, so whenever it says to find the area, we need to integrate the equation, right? So the equation we have is y is equals to 4 divided by x square. Before integration, we need to arrange our equation. So it will be y is equals to 4 x to the power minus 2. Right? Now the function is ready to integrate. So it's x to the power minus 1 divided by minus 1. And at this time we are not using the variable constant c here, because if you see the region A, so what are the limits for region A? Region A starts from 1 and ends at 2, right? So that means we need to place the limits here. That means it's from 1 to 2. So this negative sign, when I take it outside the bracket, so it will be minus 4. And x power minus 1, it's basically 1 over x, and we have the limits from 1 to 2. So it's negative 4, applying the upper limit, it's 1 upon 2, minus lower limit, it's 1 upon 1. So it's minus 4. 1 upon 2 minus 1, it's minus 1 upon 2. So minus minus plus, and 2 2s are 4. So the value of the integration, or you can say the value for the area, is 2. Alright, now if we are going to attempt for part B, in which it says the region, we need to find the area of region B. So we need to start from this part, right? After integration, it's minus 4 1 over x. Now for part B, only the limits are changing, the equation of the curve is same, right? So the limits are up, lower limit is 2 and upper limit is 3. So it's minus 4, upper limit is 1 over 3 minus lower limit is 1 over 2, negative 4, taking LCM 6, 2 minus 3. Alright, so it will be minus 4 over 6, 2 minus 3, it's minus 1. So 2 2s are 4, 2 3s are 6, so that will be equals to 2 over 3. Alright, clear? So that's how we need to find the area of the shaded region by using integration. So after this example, we are going to start the exercise. It's 21.1. Question number 1, there are few parts and we are going to attempt some of them. So firstly, it's part A and C. In your first part, you have an equation y is equals to x times 4 minus x, right? We need to find out the area of the shaded region, and that means first we need to integrate, right? But before that, we need to multiply this equation. So it will be 4x minus x square equals to y. Alright, now the function is ready to integrate. So when you integrate it, it will be 4x is 4x square divided by 2 minus x cubed divided by 3, and limits you have, it's from 0 to 4, right? 2 1s are 2, 2 3s are 4, so it's 2x square minus x cubed divided by 3, and limits we have from 0 to 4. Now I am placing the values of limits here. So upper limit is 4, so it's 2 4 square minus upper limit is 4, so it's 4 cubed divided by 3, upper limit, minus lower limit, it will be 0 because the value of x is 0. Alright. After that, 4 square 16 2s are 32 minus 64 divided by 3. Taking LCM, that will be 3, 3 2s are 6, 6 2s are 9, 96 minus 64 and divided by 3. So we can easily find out 96 minus 64, 32 divided by 3 is 10.66. Alright, so the answer is 10.66 for the first part. Alright, then I hope that it is clear to you. Now for the next part, that is part C, the equation we have is y is equals to x square plus 1. So you need to find out the area of the shaded region, and you must observe that the starting point is not 0 now. The starting range is 1. So lower limit is 1 and upper limit is 2. Alright. So you need to first write by yourself and write down the solution for first part A in your copy, and then try part C, and for these two parts you have a time of 2 minutes. So start. Alright, so first when you integrate it, it will be y is equals to x cube divided by 3 plus x, and the limits we have, it's from 1 till 2. So applying upper limit, 2 cube is 8 divided by 3 plus 2, that is my upper limit, minus lower limit is 1 upon 3 plus 1, right? So when I expand the brackets, it will be 8 over 3 plus 2 minus 1 over 3 minus 1, right? The LCM, it's 3, so it will be 8 plus 2 3s are 6 minus 1 minus 3, right? So 8 plus 6, 14 minus 1, 13 minus 3 leads to 10 over 3. That is your answer. Alright, so moving towards the next part, it's part E, and it contains the exponential function. So we have y is equals to e to the power x plus 2, and the limits it from 0 to 1. So first give it a try, and you have a time of 60 seconds. So start. Alright. When you integrate it, so the integral of exponential is exponential, and the integral of 2, it will be 2x, and the limits we have, it's from 0 to 1. So it will be upper limit, right, minus lower limit. So it will be e to the power 1 plus 2 minus e to the power 0, it's 1. So it's e plus 1. And that is your answer. If you find out the value of e and then add 1 into it, it is, that will be right as well, and this answer is right as well too. After that, part h, y is equals to cos 2x, right? We need to find out the area, and the limits we have it 0 to pi by 4. Let me remind you one of the important things that I told you in the previous classes, that whenever we are dealing with trigonometry in calculus, that means differentiation and integration, make sure that your calculators are in radian mode. Alright, so first you need to give it a try by yourself, and time is 60 seconds, and then I will explain. So start. Alright, so we have y is equals to cos 2x. The integral of cos is sine, but when we have the derivative of angle with it, right? So you need to multiply and divide it by 2. Alright, now the function, this function is ready to integrate. The integral of cos 2x, it's sine 2x, and that 2 in the denominator, and we have a limit from 0 to pi over 4. Alright, So 1 upon 2 is a constant taken outside, coefficient, sorry. Now when you apply the upper limit, it's sine 2 times pi over 4 minus sine lower limit is 0. Alright, so sine 0 is 0. So 1 upon 2, 2 1s are 2, 2 2s are 4. So sine 90 it's 1. Alright, it's sine pi by 2, which is sine 90, and that is equals to 1. So your final answer is 1 upon 2. Alright, so after this question, moving on towards the next question, it's question number 2. Alright, so we have two parts, and if you observe, so you have a curve and a line. Alright, if we focus on the first part, the goal is same, that we need to find out the area of the shaded region, right? But the strategy is little bit different as compared to the first part, because in question number 1 all we have is a single line or a single curve, and we need to find the area of the shaded region, right? But in this type of question you can see that there are two equations, or one is a curve, one is a line, or there might be two curves, two lines, whatever it is. But how to solve such type of question, right? So if you observe the curve part, that is your curve part, right? The area under this curve part is this one, right? That is the area under the curve. For the part that is present at the right side of it, this one, that is not the area under the curve, that is basically area under the line. Alright, or you can say that this shape is a triangle, so it's basically area of a triangle. So the curve equation we have, it's y is equals to x square plus 1, right? First we need to integrate it, because we are looking for area. So the integral, it will be x cubed divided by 3 plus x. And when we apply limits, so the curve shaded part is from 0 till this point is 1. So it's from 0 till 1. Applying limits here, so upper limit it's 1 over 3 plus 1, and for lower limit it will be 0, because the value of x is 0. Alright, so 1 over 3 plus 1, it will be 3 plus 1 4 upon 3. So that is the shaded area under the curve part, right? If you talk about this shape, so that is a triangle, right? The coordinates are 1, 0, and to find the area of a triangle, we can easily apply the working formula 1 upon 2 base into height. So 1 upon 2, what is the base we have? From 1 to 4, the base part is 3, and what is height? This one, the height is 2. So the area is 3, right? So the total area of the shaded portion is 4 over 3 plus 3 leads to 3 3s are 9, 9 plus 4, 13 over 3. Alright, so that is your first part answer. I hope now you have a clear idea how to find out the area, how to apply limits. Now, if you talk about the second question, right? If you consider the area below the shaded region, this curve, so it is from 2 to 4, right? This part is lie under this curve, this one. But what about this one? So this one, now it is a rectangle, right? It is a rectangle. So when you integrate the function, the limits you are going to use is from 2 to 4, and then you need to add the area of rectangle in this one. Alright, and I'm going to apply the same. So firstly, the equation of curve is y is equals to 8 divided by x square. We cannot integrate it yet. First we need to arrange this equation. So it's 8, and when you shift x in the numerator, it's x to the power minus 2. Now the function is ready to integrate. So it will be 8x to the power minus 1 divided by minus 1. Or we can say that it's minus 8 divided by x, right? Or you can say in this form, minus 8, and x power minus 1, it's 1 upon x, and the limits we have, it's from 2 to 4. Alright, so when you apply the upper limit, it's 1 upon 4 minus lower limit 1 upon 2, negative 8 outside, LCM is 4, so it will be 1 minus 2 minus 4 ones are 4, 4 twos are 8, so it's minus 2, and 1 minus 2 minus 1, that leads to 2. Alright, so that is your area for the curve part. For the highlighted area, it's basically a rectangle or a square. It's a square, right? So the area of the square, we have 2 into 2, that is 4, right? This length is 2 and 2 square is 4. The total area, or we can say the shaded area we have, it's 4 plus 2, that leads to 6. Alright, so I hope that it is clear to you. And to find out the area of the shaded portion, what we need to understand or highlight is, we need to highlight the limits below that curve or the shaded region, or we need to highlight the shapes we are going to get, the triangle, rectangle or square. Right, so make sure that you are reading the value of limits carefully. Before proceeding to the next question, you need to write down these two parts in your copy, and to write down these two you have a time of 2.5 minutes. So start. Alright, moving towards the next question, it's question number 3. Find the area bounded by the following. For first part we have y equals to x cube, x equals to 2 and x equals to 3 and x axis. Alright, so this question is similar to question number 2, except the fact that in question number 2 we have a perfect graph, but in this question we need to construct the roughly sketch first, and then it will be easy to find out the area. Now the first thing, we need to plot the graph of y equals to x cube. So y equals to x cube graph follows this pattern, right? That is y equals to x cube. Alright, after that it says x equals to 2. So let's suppose this value x is 2. So x is 2 is this line, that is x equals to 2. X equals to 3, similarly it will be this line, right? X equals to 3 and x-axis. So the shaded region we are getting is this one. That is the shaded region. Alright, so first you need to give it a try. First draw this draw this roughly sketch in your copy, and then start to find out the area of this highlighted region, and you have a time of 3 minutes to attempt the first part by just drawing the curve on your copies roughly, and then find out the area of the shaded portion. So start. Alright, so what I expect that you have done is, the equation of curve we have, it's y equals to x cube. To find out the area we need to integrate the equation. So it's x4 divided by 4. Applying limits we have from 2 to 3. Alright, so the upper limit is 3 to the power 4 minus lower limit is 2 to the power 4 divided by 4. 3 power 4 is 81 minus 2 power 4 is 16 divided by 4. So 81 minus 16 it's 65 divided by 4, and that is equals to 16.25. Alright, so that is your answer for the first part. I hope that is clear to you. Now for part B, still again you have the same type question, right? Y equals to 4 upon x square, x equals to 1, x equals to 3, and the x-axis. So you need to attempt it in the same way as I had discussed it, but the important thing is you need to roughly sketch the curve of y equals to 4 over x square. Alright, so you have a time of 5 minutes for this part, so start. Alright, so firstly, if I sketch the roughly graph here, so y equals to 4 over x square, the curve will be like this. That is a curve of 4 upon x square. Alright, it will be on the negative side as well, but I am not focusing on the negative side because the x values are positive. So x equals to 1, it means this line, right? That is x equals to 1. X equals to 3, it means this line x equals to 3, and the x-axis, so the shaded region we have for this question is this part. Alright, so now it's very simple. The equation we have, it's y equals to 4 divided by x square, and the limits we have, it's from 1 to 3. Firstly I need to arrange the equation, so it's y equals to 4 x to the power minus 2. Now the function is ready to integrate, so 4 the x power minus 2 it's x power minus 1 over minus 1, and the limits it's from 1 to 3. So now it's minus 4 1 over x, and limits are 1 to 3. Now the limits we have, it's first apply the upper limits, it's 1 upon 3 minus 1 upon 1. Taking LCM inside, so it will be 3, and it's 1 minus 3. So now it's minus 4 over 3, and 1 minus 3, it's minus 2, which leads to 8 divided by 3. Alright, and that is your answer. Alright, so I think that it is quite enough for today's class. And for the homework part, what you need to do from the same exercise, you need to attempt question number 1 part B and D. Alright, we have done question number 1, question number 2, and question number 3 in this session, and in the upcoming session we are going to start from question number 6, 7, and 8. Alright, make sure to revise the concept thoroughly, so it will be very beneficial for you for the upcoming classes. So see you in next class. Take care and Allah Hafiz.